Hello everyone. So today we will be solving the daily Leetcode problem of Leetcode, that is word break. So I hope if you would have come to this video, you would have already read the question. So let me explain the question in a very brief fashion. So we will be given a string s, that in the first example, if we take the lead, it will be given like Leetcode, and it will we will be given a list of strings, and we need to find if we can break the given string in such a way that each broken string or each broken string is found in the dictionary, word dictionary. Like if we take this example Leetcode, so if we break here after t, then lead and code, these two will be different words, and these two different words will be found in the word dictionary. Also note that each and every word in the word dictionary can be used more than once, because it is given in the question that note that the same word in the dictionary may be reused multiple times in the segmentation. So I hope this first example is very clear to you. Now let's move on to the second example. The string given to is apple, pen, apple. Now if we break this at after e, then the first word will be apple, and apple is found in the dictionary. And if we break after n, then pen, it will be pen, and pen is also found in the dictionary. And after n, if we will break it, we'll get a third string that will be apple. Again, it is found in the word dictionary. So we can simply return true, because this string can be broken down into a sequence of strings which will be found in the dictionary. Now let's move on to the third example. Cats and dog. Cats and dog. So if I break at cat, if I break at cat will be found. But let me explain this test case using whiteboard. Yeah, so we have cats and dog. So I have, if I start from here, I will be maintaining I will keep a set data structure which will be having all the dictionary words. And if I break at this index, 0th index, will I be having C in my dictionary? No, I will not be having C in my dictionary. However, if I break it at A, I won't be having. But in case if I break it at T, will I be having something in the dictionary? Yes, I will be having. So I will be calling function next recursion function for this string. Now can I break at this also? Yes, I can break at this also, because cats is already because cats is also present in the dictionary. So another recursion function will be called for a and dog, right? And can we break at any other locations? No, we cannot break at any other locations. Now can I break at s? No, I cannot break at s. Can I break at a? No. Basically this whole string will return a false from here, and this whole string will again return a false from here. So uh, if we visualize this question in a recursion fashion, we will find that this problem has multiple recursion uh, multiple recursion height. So this problem can be solved using recursion. Why? Because at each index we have many options to break the string, and if we have to try all the possible options, we use the first algorithm that should come to our mind is a recursion algorithm. And if there are repeating recursion calls, we will think something of dynamic programming, right? So yes, now let's move on to the coding section. The coding is easy. See, what we are actually doing is we are creating a multi-set. Actually no need of multi-set, because we will be using a single word multiple times, so we can simply use set also. But nevertheless, I have used multi-set, no problem with that. And then I'm creating a dp of size s dot size and initializing it with -1. Now what I'm doing is I am simply pushing all the dictionary words of the dictionary, string words of the dictionary in my set data structure, and I am simultaneously calling the recursion main function for the which will be passing the string s, the multi-set, and the 0th index from where I am starting, and also the dynamic programming vector. I hope till now this function is very clear to you. Now I will try to explain you this solve function. So what the solve function does, whenever recursion is performed, there has to be some base case where the recursion must stop and the process must return back to its original original location from where the recursion has stopped started. had it not been had it not been this way, the recursion will go on infinitely, and it will consume a lot of memory, and time limit exceeded will be given, and also your heap memory stack, so not heap memory, stack memory will be completely filled. So now let's check what will be the base case. Suppose my index that I am iterating on the string s reaches to the end of the string, or reaches after the end of the string s. So what I need to actually do at that point, it means that till now everything has been find out, and I cannot do any further. I cannot do any further further recursion calls. So simply I'll return true from here. Return 1 means return true. Also the standard memorization code is here. If dp of index mine is not equals to -1, I'll simply return dp of index, and I am initializing an answer that will be initialized with false. Now from the index I to the last index of s dot size -1, I am trying out all the possible partitions, and if this partition like string x is equals to a substring index I minus index plus 1, I minus index plus 1 is basically the length of the current partition. Like if I am at my index is equals to 0 and my I is equals to 2, how many alphabets are there between index and I? There are 3 alphabets. So how we can find out that I minus index plus 1 starting with index? So I am trying to I am trying to include that current substring and checking out if my multiset is having this substring or not. In case if this multiset is having this substring, we can simply make a partition over here and then call the further recursion calls. If any of the condition return true, my whole process will return true, my whole recursion call will return true. So if any of the recursion call returns true, what does this mean? This means that we have to use the or operator. So answer, so what we have used is answer is equals to answer, or either my current answer is false, or if my further answers are true, I am gonna return true, and in the end I am storing this answer in my dp index. So I hope this question is very clear to you. And also this submitted code I had submitted just now before making this video, so no need to submit. Like I'll show you. Yeah, so this is the accepted code that I had just 8 minutes ago. Also there was a time limit exceeded. Let me show you this code because I had used recursion, and obviously recursion will give us time limit exceeded for this cases. See, I had not used dynamic programming in this problem, so there were multiple same calls again and again in the recursion stacks, in the recursion stack, so it gave time limit exceeded. I hope this problem was very clear to you. In case if you find any if you find this video helpful, please like and subscribe my channel. Also please hit the bell icon so that you may get the further notifications for my future videos. Thank you.